Well, it looks like you're ready out there. Welcome to Turn Right Machine Works. My name is Keith, and today we have a new video for you. Now, before we get started on this video, I'm going to take a moment here and we're going to cover some of the cameras that I use in my video creating. And only because I know that during this video or in the comments after this video, I'm going to be asked, what do I use for cameras? The project we're going to be doing is going to entail a little bit of weld buildup and then a little machining, and I'll get you in close and we'll talk about the scope of that project here in a second. Now, my videos actually all started when the wife Vanessa bought this little Vadu HD camcorder, and I think she got that on the shopping channel at night or something like that. But I played around with it a little bit, and then it kind of sparked the interest, and then I went out and I actually shopped, and I picked up, this is my second one here, but this is a Canon Powershot. Over half of my videos are created with that Powershot. That's the second one I've had. The first one, I think 2 weeks of using it, I had a lens malfunction, and of course the Best Buy upholds their warranties really good, and I walked in the store and 15 minutes later I walked out with that one, and you know, what is it, like 4 years old now, 3 years old, something like that. So I started, and I've done a lot. I've picked up a camcorder smaller than the one that you have, a Canon. The Vixia M30 or M40 was the one that I actually liked, and this is an M50 here. It's a little bit bigger, but the other one had the great zoom. In fact, that was the one that I actually started creating some of the good zoom shots on the lathe, like in the Beaver episode. And I was coming in, I was cutting that weld, that radius on that weld. That camera was giving me that shot, and I kind of miss it. I also have the NEX6, and that's going to be taking some close-up welding shots. Now, I've been, ever since the Heat and Tweak video where I was working on the aluminum welding there, and I accidentally stumbled in on the combination that was close enough to actually start seeing arc shots. And since then I've been playing here and there, and over the weekend, especially yesterday, I sat down quite a bit and was really playing with this camera and the combination that I have. I haven't bought a new camera in 2 years, or a year ago last Christmas was the last time I picked up a camera, and I think it was the NEX6 here. I also have a Note 4, which I upgraded from the S4 phone, and I also do video with that. So that's kind of my combination of cameras that I have. Now, it's not that I have anything any new cameras that's creating the difference in my videos. Is I'm playing a little bit more with the editing. I use Camtasia, and some things have to be rough rendered with Windows Movie Maker, and then I go ahead and after that then I put them into Camtasia, and that's where you get a lot of your effects there as well. Now, I've been breaking out and like the microphone now, so that when the air compressor comes on, or when the welding machine is on, or the lathe or whatever, you'll be able to hear my communication much better, hopefully. And so far it's proven out to work fine, and this will be the test of working up here with the welder going. The other accessories like filters and macro lenses and those kind of things, I'm starting to play around with those and put them in combinations to where they are working for me and helping get better shots. So not only the weld shots become a little better, because I really enjoy welding shots that Jody at weldingtipsandtrick.com puts on his site, and I think it's very, very important, because actually when you're learning to weld, you need to look in and you need to see what's going on in that puddle. That puddle how that puddle's flowing, the area around that puddle. You need to be focusing. I mean, you have direct vision right into that puddle, but your peripheral vision of around that puddle as well, what you see happening around there, and the leading edges for undercutting or wash over or things like that. Some welds, stick welding, 7018 and stuff like that, is very hard to differentiate the puddle and the flux flowing around it. And yet, you know, there's some good arc shots that I've seen that Jody puts out, and you can actually see what's actually going on, and that's paying attention to the puddle itself. Now, I'm not here to tell you and show you how to weld, but I'm putting this in here so that you could see how I get her done. And so anyhow, let's go ahead, and I'm going to break the camera down and get you in over here closer, and we're going to start going through the project, what we got going on and everything. I'm going to be using multiple cameras. We're going to be having all three my main cameras. The camcorder you're looking in now, we're going to be doing the weld puddle with the NEX6, and we're going to be keeping an eye on my Synchrowave 250 over there, and we're going to be watching the gauges, because you guys you're also going to be wanting to know, hey, what tungsten you use. I'll show you that, and the gas, and how I set my post flow, and because I get a lot of comments that, hey, you're letting too much gas go and everything. I have settings on that machine, and we will actually time those out. I have been setting them a little bit lower. Whether that actually makes a difference or not, I haven't noticed a difference of not protecting, and that's the main thing. Whatever it takes to protect your tungsten and also your finished weld. But we're also going to be, I use the foot pedal a lot, so it's not a straightforward setting of amperage, but you'll be able to see what is reading on the machine with the amperage. So kind of, I'm going to combine these together. It's just a small job, but I want to go ahead and give you as much coverage of this small job to get the most bang for your buck on the information on how to get something like this done. All right, let's get to it. Okay, I got you on the table overlooking our project here, and this is looking down on the top of the head. This is a water inlet here for cooling, and then we got the spark plug hole here, and then this is a support, I guess, that mounts to the frame, and then these are your hole patterns that bolt the head down. Alright, this is looking inside or under the head, and you can see the water jacketed areas, and then a couple weeping holes that go down through there as well. And there's a gasket that goes down on top of this. Alright, now when he first talked about this, yeah, I think he said, I don't know what the make is of the motorcycle, but it's I think it's right around the 350 class. And I remember thinking, when I was growing up, my big bike was the 250 MX Yamaha, and I forgot what the bore was now. I know that I had it like 20 over or so, but this is close to 78 millimeters, or 3-inch, a little over 3 1/16 or so. As far as the size of head, just for anybody that wanted to know, it's not relevant to the job at all. What is the job is to create a spot and mount this compression release. Now this is a compression release valve, and the thread on it is 10 millimeter by 1 millimeter lead, and it's the typical release, just like on a chainsaw and etc. So that thread has got to be put in so that we can mount this on the head. Now he came over and we talked about, you know, he brought over his phone and showed pictures of it mounted into the bike, and he wanted to be able to reach down and be able to comfortably get at it and everything else. So he basically, we pinpointed, and that's what the Sharpie circle is here. So we're gonna, that's the boss. That's a location of the boss, and then its height, of course, has got to be enough for me to go ahead and create a thread that's deep enough to take this and create the seat for the compression washer there, and have enough room for that plunger to go down below all of that. It's got to be 100% functioning hole that this will mount into, and that'll be all machine work after we do the build-up. Now if we look at it here, that port is going to go right between that water jacket right there and this area right here. So that pilot hole is going to come in through here, and then we've got to come up into the chamber right next to that edge right there. Now we may actually have a hole that's somewhat drilled and angled this way, and then we're going to tunnel through this web right here, and then in reality this release will be probably sitting out in that distance there if you were looking down at it. We got to have room for the poppet to work and all of that. So that's the scope of the job. There is a little pisser hole on 180 from each side here. Not that it's going to make any difference, but that's where the main exhaust will have a certain amount of escape until the pressure actually pushes the plunger shut, and then of course it's sealed after that. Alright, we got to go ahead and we picked up our taps. Now we had to do a little shopping. I mean, we absolutely didn't have this tap in our kit, and we had 9mm by 1, and we had a couple other taps that were real close, but we had like 1.25 lead and 1.5 lead on two 10mm taps, so we didn't actually have a 1mm lead. This set here I picked up because I want the bottoming tap more important than anything else. I might start with the plug and then come in with the bottoming, because I want to machine the boss with the minimum amount of stick out, but I want to go ahead and I want to create enough thread so that I know that this is threading freely, and then I'm hitting the washer here, and it looks like that button up and even the amount of in here it's gonna work out perfect. So I'm not gonna have any more hole than I'm actually gonna need to have threads and have this seat. So that's kind of the plan. I think it was like 30 something bucks for the set of taps there, including the freight. Pretty close to 40 bucks. And that's part of getting this job done. The other thing that I'm going to go ahead and do is I'm going to clamp this up, and I'm going to actually, I was thinking at first put it in my weld positioner and hold it in 4 points and everything else. But see, now we've worked for a while now on viewing weld buildup, and I want to try to give you the best view from all angles of this. And I'm going to go ahead and hold this in my little vise by clamping the C-clamp and holding it here. Then I'm able to pitch it so that I'm actually going to be vertical. Once I get this curve and this pretty well a flat plateau, I'm just going to be working straight on up. After we have the height and our diameter pretty much the way we want, then we may go ahead and lay it, roll it, position it in a couple different areas if I wanted to wash or fill an area that maybe I didn't quite get just right as we go and build this up. Now I also going to go ahead and take my center. In fact, I got it here, and we're going to go ahead and we're going to create a Sharpie line, because I'm going to take a square off the table when I go to set this up in the vise there. I got some cleaning up to do on this thing yet, but this is kind of the plan here. And so I want to create a straight line. Then when I hold that in the C-clamp, then I'll be able to pitch it like this, and that's going to give me the straight up and down line there, because I want to be able to, between passes when I have my hood up or looking through my lens, I want to see a straight aluminum castle being erected up off the part here. All right, let's go ahead and grab our tools. I gotta change out, put on a rotary burr. The burrs I kind of like or favor are this is like a 1/2 inch ball here. This is a 5/16 ball here, and this is just a cone, but this is a cross cut here. And this one here really kind of lets me just kind of massage over the surface and get rid of the aluminum that's there. This thing is not really filthy, so I'm not having to worry about baking this thing up. They've got it pretty clean there. And this surface out here was exposed, and it's very, very clean right here. So I'm going to, and all these areas are going to be very accessible. I'm not going to really be removing any material except for the oxidized surface on it, and then I'll be creating a line and redrawn somewhat of a Sharpie circle where I want to have my build up till I get it started, and I know the parameter or the diameter or circumference that I'm going to be playing with. I want enough meat around the outside, so we got to have, I don't know, let's see what we got here. Okay, that's about almost 400 there. This diameter here is almost 600. Oh, how comfortable would we be with? I'll probably end up having something like a 3/4 inch. That's about 3/4 inch right there. That's 7. This boss right here is 720, so that would kind of fit somewhat in 750, 720. Because I like to try to at least do a presentable surface finish on the outside of this thing too. I don't want it to look like a wart off the side of this thing. All right, so let's get our wrenches and we'll get changing this out and start prepping that up. Okay, I'm just kind of like checking out my burr, and I kind of like this because that little radius on that end will let me walk right into there, and then this here will let me fare out onto the outside edge. So I think that's the one I'm going to go ahead and put in here first and give it a shot. Okay, I'm going to run and grab my airline and a face shield. Okay, we got our face shield here, and blow the dust off of there. Let you see a little better. All right, and we got our burr in here. All right. Now I just got a block of wood here so that I can work on it, and you can see that. So I can tilt it up on here, and I know I'm not going to hurt anything. And I'm not. All I'm doing is like massaging it here. So we're going to see how this goes. I'm going to talk a little bit while I'm running this thing, and actually you probably tell that I got the hood down now, and so I'm working in that corner right there. Looks like it's getting right in there. I'm not having any voids in there, and you can see the new aluminum material in there. I just come up the side of this riser right here. Try to stay off the top. Don't want to put any owies. And sometimes if it's in an area where you want to make sure that you don't come up on it, the rotation of your burr, run it in the other way. If it runs off that way a little bit, you're not worried about having a mark out in here. I don't know how far back I'm going to fare this or blend the radius in. I'm not going to have any sharp corners, that's for sure. So it doesn't hurt to come back here and clean a little more area. When we get all done, we'll be massaging this whole thing to blend in, you know, to look normal. Having that little Sharpie on there actually gives you a color that you've got to try to remove there, knowing you got it clean. Okay, I got that whole area that I'm happy with that. Maybe just a little bit more over here. Let's see, where was our line at? All right. Kind of nice not having too much rotary burr, because you get those chips all over and then it feels like you're itching all throughout your whole project. And so now what we're going to do is we're going to go ahead and we're going to transfer this straight up and down line right over to the edge here, and then we're going to redraw a circle where we know we're going to be creating a visual line that we can look at and we can weld to around in the area here. And we're going to probably take a scribe and we're going to scribe that in there so that we absolutely have nothing there. We'll have a little Sharpie dot here, but I'm not going to do any more than that. The rest of it will be a circle that will get around by a scribe. Probably take a socket or a box end wrench, something like that. So what I'm doing is I'm just putting a little tiny blue line right on the top edge there that lines up with that line right there. This line right here is going to be so that I can scale or take a square it right off the table. All right, now I want to go ahead and I want to take a look at absolutely the center of our compression release. The path or somewhere in the bore, preferably in line with the center, would be great to go down through here and then drill this hole over here to match, but I got to be in there. So kind of where this is at, and maybe even to get it in to angle it or whatever, I think I'm just going to try to go in with a straight in diameter here. Now that I know where that's at, I already measured this socket on the end of here, and that is 3/4 inch diameter right there. So I'm going to hold this. I'm going to let this, there we go, that'll work. Okay, 3/4 inch. The edge of this is even with where I want it there, and I'm sighting down through this direction here. And this is just basically a good reference of our 3/4 diameter. Yeah, I can see that. Okay, now that we have that, and it actually comes up on the side of that boss there. You got to give a straight look down this way here, and you got to kind of scribe this in here, because you're going to want to see it under the hood with the mast there. Because you're going to weld right to it. You're actually going to flow over it a little bit because you want to come straight up, and you're going to be checking that diameter as we go. Okay, now that I've scribed this circle, that looks good to me. Yeah, it does look good. Alright, so what I'm going to do now, this is a spring-loaded punch, and I can go ahead and take and stitch my scribe line, so I'll have something that I can easily see a little bit better while you're welding. Sometimes in steel, it really, especially on hot roll and stuff like that, sometimes in your welding, you're underneath, you got sun behind you and the shield of your helmet sometimes, and you know, you're lacking a little bit of clarity on where you're going sometimes, and taking and center punching or creating a dot to dot, so to speak, pattern. Okay, that will let you see where you need to go ahead and put the build up. Alright, now I think we've prepped just about everything that we can possibly prep, and except for our torch, making sure we got the right tungsten and the right lens and all of that. Get set up in the vise, make sure our ground is tight and good, and then we'll go over and we'll set up our machine with the settings that we want to go ahead and perform this task with. We're going to be putting this in a vise this way, so let's go ahead and we're going to set the C-clamp so it's sitting square and flat. Okay, that's tight enough to hold it. It'll expand. We can adjust the C-clamp if we need to. We don't need to block here except for to maybe rest our arm or something. We may be building that. Alright, this is our test piece that we're just welding circles around one after another so we can play with our lighting on our camera. Alright, I think I'm gonna put this ground strap on here after I get this, because I'm gonna want to put this, I think, right down there like that. Okay, now what we're doing is we're going to take the square and we're going to set this up, and see how that's off right there. We need to go ahead and angle this. That looks pretty good. Alright, and the reason why I'm doing that is because I don't want to adjust or move this. I'm going to lock this down really tight here. Alright, because I want this boss to sit up on here and be straight in line with my object, so that when I deck it and drill it, it's going to be setting square, and it's going to look center and square to the buildup that I'm going to put on here, and then blend this outside, and it'll look like it's almost part of the casting. That's my attempt anyway, and that's kind of why I wanted to go ahead and square this up, so that while I'm here welding, I can picture just vertical from where I start, because we're not in line with any of the hole patterns that you look at from the other side. So once you start, forget looking at anything else on here except for the top of the crown, the diameter, and being straight up and down. If you really want to see how you're doing on your sides, you can actually put the scale down on the table and kind of eyeball your sides. Hey, am I going up? Am I leaning over that way? Same thing this way here. Alright, now we're going to go ahead, we can stick our ground on here now. That's also going to counterbalance on that side there. And with this set up like this, if I wanted to, I can move this anywhere I want around here. And I'm going to get another block because I want a resting area for my hand, and I want to try to not to be resting on. That's not a bad spot right there, but I know that I'm not going to be just limited to this spot right here. And well, it's firm, but you don't want to be leaning on your work and throwing things off, especially if heat transfers down here. We don't know, you know, we're hoping that nothing breaks loose on this. And this is going to let me set the camera up here and get a good view of what I'm seeing working on this. Alright, this is my Tig Torch, and basically I got the tape on here not to patch anything, just to hold the sheath from sliding down. And I run 2 lengths of TIG lead because I like to go farther than and not move around my machine. And when you have a Synchrowave 250 old timer there, it takes quite a bit to move it around. Anyway, I got a brand new, well, it was brand new today, number 6 cup. This is a water-cooled torch, and my tungsten's not real clean. I mean, I was doing the round test, but I do know that I dipped the tungsten into the aluminum on one of the passes there, and I mean I did another dozen passes, and I have a gloss on the end of here. I run a ball on the end of my tungsten, and I like the performance of the arc there, and I don't have to worry about keeping a razor sharp point. And I just downsize. If I want to be smaller, I downsize smaller to the tungsten. This is not too intricate, and the 332 is going to do the job here. So I'll pull this out and I'll go do a quick clean up on this, and I'll show you how I go about that. Okay, most of the time I use my Wilton sander here. And I use the zirconia belts. This one here has got a little bit of rust and steel and stuff like that impregnated in it, but there's a pretty clean area over here on this side, and all I'm going to do is break the ball off the side. Alright, and all I did was just take that surface area, knock the ball off, just kind of roll it on over, give it all new metal. Alright, and then the new ball will form when we start welding. And just before we start welding, I'll go ahead and fire it off above a piece of steel and make sure that I get a glossy ball. And by having a glossy ball on the end, I know I have a clean tungsten. This tungsten still has a little bit of the red there, so it's I believe it's a thoride tungsten at 2%, and that's what I'll be using. Well, I just went over the welder, and this was the first one out of this pack. And this pack, I had to I went like that, and I got dust all over my sweatshirt here. It's been set up on the welder so long, it's actually had a layer of dust on it, and that's what it is. It is 2% thoriated. So anyhow, and I mean, I have brand new ones in there. I have plenty of them, but I'm not done wearing this one out. And you know, after it gets down here a little bit, before it gets totally too short, I'll throw it into a section, because sometimes you got to pull this off of here and you got to put on your short cap, and it's kind of nice to have short tungstens to play around with as well. Alright, now I like probably about 3/16 of an inch to stick out to start. Alright, now this is ready. Now we can go set up the welder.